Welcome back to this video, and in this particular video we are going to talk about continuous compounding. So this particular topic, it belongs to your CFA Level 1 Book 1, that is Quantitative Methods, and that to chapter number 1, that is your rates and returns. So before I tell you what exactly is continuous compounding and what is the formula, let's go through an example story, alright? So for example, you buy an asset today at say $100, and after a year you sell it for 110. So the profit, as you can see, is how much? $10. So if I tell you how to calculate the holding period return, HPR, you can pretty much write it as P1 minus P0 by P0, which you are already aware about, right? This HPR, I can also write it as capital R, just for sake of simplicity. So the R is P1 is 110 minus 100 by 100. So you can see that this is 10 by 100, or it is say 0.1, or you can write it as 10%, right? Multiply by this. If you multiply by 100, it will be 10%. So for holding your asset, which you have brought it for $100 for 1 year, you get a return of 10%. So this is basically what we normal people understand, right? So when you hold an asset, and if the value of the asset appreciates, you get a profit, and this is how you calculate the return by holding that asset for a particular year. So this formula, let me write it down here. R is equals to P1 minus P0, right? I can write this formula like this as well, right? P1 by P0 minus P0 by P0. So basically I'm breaking the denominator. This cancels, so it becomes 1. So I can write it as R is equals to P1 by P0 minus 1. Hope it is clear till now. So this as well I can write it as R plus 1, because if I want to bring this 1 to this side, it becomes plus. So R plus 1 is equals to P1 by P0. So what I want you to do is, I want you to remember this. So this is not a formula as such, but we are going to use it to derive our continuous compounding. So let me, till this point, I hope everything is pretty clear. So let me give you one case in the sense, whenever you are given this holding period return, which is R, and from this R holding period return, you want to find out small r, and this small r is basically your continuous compounding rate. So basically, and for now, just forget what continuous compounding exactly is and what is this small r. Just forget about it. I'm going to eventually tell you. So just remember this fact that whenever you, from holding period return, you want to derive or you want to calculate small r, you are going to use this formula which I am going to tell you. So basically, to calculate continuous compounding, that is small r, we have to use log, alright? Or log is also written as ln also. So you can write it any way you want. And the formula for continuous compounding is R is equals to P1 minus P0. Okay, let me just make this. So this is the formula for continuous compounding, and this formula we are not going to use it as much, but from this we are going to derive, right? So we already know that P1 divided by P0, you can write it as 1 plus R. Alright. So instead of, I'm going to write in a log, instead of P1 divided by P0, I can just write 1 plus R, right? This one. I hope this is pretty clear. So basically, coming back to the first case which I was telling you here, whenever you are given holding period return, which is the big R, you can use, by using this formula, you can always calculate your continuous compounding rate. I hope this is pretty clear. Let me repeat. Whenever you are given a holding period return, big R, okay? And using this formula, you can calculate your small r, that is continuous compounding rate. I have not yet told you what exactly is continuous compounding and how are we exactly going to calculate and what is the difference between holding period return and continuous compounding. So just stay tuned and I'm eventually going to tell you step by step. Alright. Now I have brought out my calculator and this particular formula wherein we are using log, you need not calculate using paper, pen or manually, alright? You can pretty much using this formula easily calculate your continuous compounding because your log function is given here. So in your financial calculator. So if you see this, I'll just highlight it in my YouTube in the video. So you can see the highlighted, this is particularly log, ln means log, and above that e to the power x is written, right? That is Euler's number. So just focus on the log for now. So in the above scenario, the big R was given as 10%, right? So if I want to, from this, holding period return is 10%. So from this, if I want to calculate the continuous compounding for the same thing, then I just have to plug in the value. R is equals to, so this formula is very important. This formula is very important. Okay. You need not remember this one. You need not remember this one. Okay. But this one is important. So whenever you want to, again, whenever you want, you're given the holding period return, you can always compute your continuous compounding. So if I, for the above example, if I plug in the value, this is log, I can write it as ln 1 plus r. R is 10%, right? Or you can write it as 0.1. So 0.1. So R is equals to ln 1.1. So R, if I go to my financial calculator, what do I need to do is, I just need to tap 1.1, which is inside the brackets, and just tap ln. You get the number there, right? 0.0953. So your continuous compounding rate is 0.0953. Or if I write in terms of percentage, it is 9.53. Okay. So the continuous compounding here, which we have got, is 9.53 and our holding period return is 10. Alright. So why is this continuous compounding lesser than your holding period return? So in our case here, R is smaller than big R. Why is this? So to tell you what exactly is continuous compounding and what do I mean by all of these, so let me present you with a simple analogy here. So you can see two person here, alright, person A and person B. And they start from this point A, starting point, and the destination point is this. And here, as you can see, it is $100 and they both are kind of reaching 110, which was in our case here. Alright. So person A, basically imagine that he is representing your holding period return. So starting from here to reach this point, instead of walking, he's doing a big jump, quick and big jump. So basically he is doing one movement, one quick big jump movement. And the speed of that one movement is 10%. Okay? Whereas in our case of person B, instead of doing jump, he is continuously running, or he is continuously walking at one particular speed, which is 9.53. Okay? And he reaches the same destination. To reach the same destination as person A, he has to walk by what speed? 9.53. So his body is in continuous movement. So this exactly is what continuous compounding means. So if I tell you holding period return, if I say it is one movement, but continuous is like it's happening continuously. So holding period return, this 10%, it is applied once. Okay? One movement. It is applied once. But continuous return, what it says is that this 9.531% is compounded or is applied at every instant. Okay? So this basically is your continuous compounding. So in previous videos and all, you might have, we have talked about non-annual compounding, right? In that we learned about there is something called annual compounding. And then there is semi-annual compounding. So semi-annual compounding is like, suppose you start at $100 and suppose the interest rate is 10% per annum. So what happens is, like, since this is semi-annual, after 6 months, semi-annual, half of this, because this is per annum, 5% will be applied. So it becomes 105. Again, for another 6 months, 6 months, 6 months, on this 105, again 5% will be applied. Okay, so it will become like 105 into 5%. So it becomes 110.25. Okay, so basically in your semi-annual compounding, your interest is calculated or is applied 2 times a year. So for quarterly, your interest is applied 4 times a year. For monthly, it is applied 12 times a year. Okay? And for daily, it is applied 365 days a year, because there are this many days. But for continuous compounding, it is applied not only every day, but and also not only every hour, every minute, every second, every microsecond. You can go ahead with for this thing. So basically what I mean to say is that here the compounding was taking once a year, twice a year, 4 times a year, 12 times a year, 365 days a year. But in case of continuous compounding, the compounding is happening at every instant. Okay, every instant this compounding is happening. So in such cases, whenever compounding is happening at every instant continuously, then you call it continuous compounding. Okay, and if it is happening in a structured way, you get these, alright, which I have told you in the video of non-annual compounding. Okay, So if the compounding is happening at every millisecond and every instant, it is continuous compounding. So this is the basic definition or the concept of continuous compounding. I hope till this point everything is clear, and let me remind you again that, let me bring back to that question again. Whenever you are given holding period return, which was one big movement, and you want to know for the same, if the starting point is same and the destination is same, for that big R, your continuous compound, your holding period return is given, and if you want to calculate the continuous compounding, small r, continuous compounding rate. Hope you understand. Yeah. So the formula was what? R is equals to log ln 1 plus R. Okay. This was your formula. What if I tell you, now if continuous compounding is given, I want to know my holding period return, and the condition stays the same. The starting point and the finishing point will be same. So for that, continuous compounding is given, that percent B rate is given, and you want to know the holding period return. So in that case, what is the formula if I want to convert back? So the formula for that is, there is something called, you can see in my financial calculator, the ln, right? I'll be highlighting it. So above that, EX is returned. So that E is basically Euler's number. So this log ln and this E are inversely proportional to each other. So if I want to cancel the log, I have to introduce E. So E to the power R. Okay, I'm just introducing E to the power log 1 plus R. So since this particular E and this log are inversely proportional to each other, and as you can see from financial calculator also, if I want to use E, then I have to press second. You can see that EX is getting highlighted. ln has gone done. Okay. So they are inversely proportional to each other, so they'll kind of cancel out. And then ER is equals to, you can write it as 1 plus R. Okay, you can bring down just like that. And your R, basically this R, this one will go this side. So it will become minus R. So I can write it as R is equals to ER minus 1. So this is the formula by which you can convert your continuous compounding into your holding period return. So let's just check it out. Why not check it out, right? Our continuous compounding was 9.53. So in this case, our small r was 9.53 percentage. Okay. And we want to know R. R should be 10. Let's see if this holds true. So I can just write 0.0953. So there are two ways to calculate here. The value of E, you can put it and then you can use the financial calculator, or you can straight away use the EX. So let me show you how you can do it. So the first way, the value of E, which is your Euler's number, just like you have this pi, right, in circle. Pi was 3.14 if I remember. So something like that. The value of E is, it's a constant, 2.718. Alright. So if I want to calculate big R, which is, and then ER minus 1, and R is how much? This 0.0953 minus 1. E is how much? I told you this, 2.718 to the power 0.0953 minus 1. Let's just plug in 2.718 y to the power x. I'll just tap it, then tap 0.0953, right? And then I do minus 1, which is coming out to be 0.10, right? So this is what exactly we are getting. So if I want to change into percentage, multiply by 100. So 9.99, which is like 10%. Okay, this is the first way to calculate. What is the second way? Second way is by tapping your this. Let me just show you. Let me clear. So here, what do I want to do is, if you forget this value of E, you can just use the EX. So first, I have to tap the value of R. Okay, R is how much? R, small r is this one. So 0.0953 second EX. Okay, then again minus 1 into 100. Hope it is clear. Let me again repeat it. The formula stays the same. Okay, you don't know the value of this E, so but you have this R, so you just tap the R, 0.0953. So we want to use the function EX, so I have to press second. It gets highlighted, right? Log becomes dull. So I'm using EX. It gives me this value, and this minus 1 I'll deduct, minus 1. And if I want to change it into percentage, so this is what exactly you get. So either way you can do it. You can put in the value of E, or you can just use your financial calculator, which makes the life much easier. Okay, so till this point, let me remind you before going ahead that we have learned what actually is continuous compounding. Okay, what is continuous compounding? Second thing we have learned is how do we calculate or convert from your holding period return to your continuous compounding, given that the starting and finishing is same. And then second condition, third thing we have learned is from continuous to holding period return also we have learned. So if you remember just this formula, you can remember this one as well. You need not remember this one as much. If you just know the concept, okay, E and log, Euler's number and log are inversely proportional to each other, then you can just plug in this formula and then you can derive this one as well. So I encourage you to basically learn this formula and practice with your financial calculator. So hope till this point everything is very clear. Now let me tell you the formula for continuous compounding. So up till now, we have not exactly seen the formula for continuous compounding. We just have seen that from your holding period return, bigger, how do we derive this continuous compounding, or from continuous to holding period return. So let me tell you the formula for your continuous compounding. So continuous compounding formula. So it looks something like this. So future value if you want to know, and you're given present value. And if the condition is that it is being compounded continuously, then you write E R. R is the continuous compounding rate. into P. Okay. So here the basically FB is your future value, PV is your present value, your R is continuously compounded rate. Okay. And T is your time. So let me give you an example question so that we can solve a particular example, and using that we'll be better able to understand this formula. Okay. So let me just write a question here. Example question. Suppose continuous compounding rate, your continuously compounding rate is 9.53%. Okay, just giving a random example. So after 3 years, value of $100 if continuously compounded would become what? I've just made up a question. All right. So suppose you are being given the continuously compounded rate, which is 9.53, and after 3 years, value of this $100 if continuously compounded at a given rate would become what? So using the above formula, we know that this $100 is your present value. Time is given 3 years. Okay. And your continuous compounding rate small r is 9.53%, which I can write it as 0.0953. So if I plug in future value is equals to present value into E R P, right? Present value is 100. E R is 0.0953. T is 3 years. So let me just calculate this part. 0.0953 into time 3. Okay. So this has become e to the power 0.2859. So if I want to use this e, then what we do in the financial calculator, the value of this thing is already there. So I just want to use the value of e. Then we have to press second, that ex what highlighted, press e, right? And this is the value of which is shown in the financial calculator. So you just multiply by 100. So your future value is 133.09. Okay. So this is how you use the formula to check or to know if your present value is given, and if your continuously compounded rate is given, then you can easily calculate your future value. I think, hope till this point everything is clear. Now let me twist the question in such a way. I'm trying to explain you the best possible way I can, so that there is no confusion. All right. So in this particular scenario, your future value was given, your present value was given, your continuous rate of compounding R was given, your time was given, and you need to calculate this future value, right? But suppose if I ask you, Your future value is given, your present value is given, your time is given. Calculate R. How are you going to calculate this R? That's another tricky way, alright? So, in this particular question, if I just tweak it, this particular thing is not given. Instead, it is written that the future value is this. Okay? So, present value is 100, future value is 133.09, and this is compounded continuously for 3 years. So what is the continuously compounded rate? If I tell you this, how are you going to calculate? So let me just plug the same formula. Okay, so future value is equals to present value into e to the power RT. Future value, I can take this present value that side, right? It will go in the denominator. So y present value is equals to e to the power RT. Okay. Future value is how much? 133.09 divided by present value is how much? 100 e to the power RT. So just let me write 133.09 divided by 100, which you need not use financial table, you can easily see. So it is 1.3309 is equals to e to the power RT. So I told you above that if you want to cancel e, which is real number, you have to bring in log. Okay. So if I bring log, it will be something like this. Okay. And if I bring this log here, it will not go up, but it will remain here. So this log and e will get cancelled because they're inversely proportional to each other. Alright. And this becomes law of ln, I should write 1.09. Always remember that log is inversely proportional to this e. So they cancel each other. So I'm not exactly here. So it becomes RT. So ln 1.3309. R we need to find out. T is 3 years, right? So this value is already there in calculator. I just have to press log ln. I just press ln, it becomes this 0.2859. So if I bring this 3 that side, it will become come to denominator. 3 is equals to R. So I just have to divide 0.285 by 3. So you get the value of R, which is 0953 is equals to R. If I write in terms of percentage, it is 9.53 percentage. Alright. So if you check, it was exactly 9.53. We just use the reverse engineering to get our value back. So I hope till this point everything is clear. I have told you continuous compounding, what exactly it is, from holding period to continuous, from continuous to holding period. And I have showed you the formula of continuous compounding from given a present value and given the rate of continuous compounding, how you can use your financial calculator to get your future value. Or if these numbers are provided, how are you going to calculate the continuous compounding? So hope till this point everything is clear. Going ahead with the last topic of this video, the particular section in your book is not that elaborative, it is very small, but I'm trying to teach you this because this continuous compounding is very much applicable and useful in your entire CFA curriculum. And also this continuous compounding is used in real case scenarios like your stock market, the movement of stock market. If you see when they are active, it is moving every second, every millisecond, 4 seconds, 4 milliseconds and all. So the price of the movement is continuously there. So this particular thing is very much useful, but the rate changes in there. But still it is very useful. And let me tell you one of the last benefit of continuous compounding, and with that this video will be over. Yeah, this is the last topic. To save time, I have just written it. So basically one feature of continuous compounding is that continuous returns can be added, but normal returns cannot be added. So this is one of the benefit which is highlighted in your CFA book, particularly mentioned there. So let me prove that point through this particular one question. Suppose there is an investment which earns 10% in year 1 and 20% in year 2. Can we simply add these two normal returns and say that 10 plus 20 is 30 returns? Let's just check. So if I calculate the holding period return, so this holding period return HPR or the big R this is for multiple years, right? So I can just write 1 plus R1, if you remember the formula, 1 plus R2 minus 4. So 1 plus R1 is how much? 10%. I can write this. R2 is how much? 20%. I can write like this, minus 1. So 1.1, 1.2 minus 1. So if I do the calculation, 1.1 into 1.2 minus 1. So this is giving me 0.32, which is 32%. So 32% is not equal to your 30% when you simply add these two figures. So this is wrong, right? You cannot add it. To validate this point, that this actually is coming out to be 132, you can also do it traditional way. So suppose imagine you had $10 at the start, and in first year there is a 10% gain. So if I calculate here 100, 10% gain will be 110%, right? Equals. That becomes this. And after second year there is a 20%. So I just have to multiply it by 120%, right? It becomes 132. So there is a jump of percent. So the point is that if normal returns are given to you, you cannot add it. Hope it is clear. And what about continuous return? How do I calculate continuous return? So can I add this continuous return? Let's check. So for the year 1, let me write in pink. Continuous compounding would be what? You remember the formula, right? Log 1 plus R1. Okay? Your R1 is this one. It's given log 1 plus 0.1 log 1.1. This is coming out to be, let's check, 1.1 log. It's coming up to be 0.0953, or you can say 9.53%. What about year 2 continuous compounding rate? Log 1 plus R2. R2 is this. So I'll just write 0.2 log of 1.2. So 1.2 log. It is coming out to be 18.23%. So if I add 18.23 plus the first value, if I add this to 9.53, this is the continuous compounding. So simply in this case, you can add year 1 continuous compounding with year 2 continuous compounding, and this is your ultimate continuous compounding. Let me validate it through 2 ways, as I told you. One is your future value is this, your present value is this, right? So present value is this, future value is this. So you remember future value is present value into E RT. This was the formula for your this thing, continuous compounding, right? Continuous compounding. So this 27.76 is for 2 years. So this RT should be equal to this, because R would be 1 year, but 2 years, right? So this should become this. Let's see. This is 132, right? Present value will go here, denominator 100 ERT. So it will be 1.32 ERT. Okay. So if I put log on both side, ln 1.32, this E will get removed, RT will be this. Okay. Because if I put log here on the right side, log, then ERT, this will get cancelled, RT will only remain. Hope you remember. So 1.32 log, okay, into 100, since I want to convert into percentage. So this value is coming out to be 27.76, which is exactly this. So that way also I validated, or you can validate in other way as well. Let me stretch it a bit. You can, if you have this continuous compounding, you can always compute this big R, right? That is holding period return. And the formula with R is equals to E to the power R minus 1. So this E R is 27.76. I can write it as 0.2776 minus 1. So if I calculate 0.2776, I want to use E to, in that case, I'll just press second EX, right? And then now I have to subtract minus 1, multiply by 100, because I wanted percentage 31.99, which is exactly 32%. So in our holding period return, it was also 32%. So we have validated in both the ways. Alright. So the conclusion is that you can add up you can add up continuous compounding, but you cannot add up holding period return or your normal return. So I know that this particular video is a little bit confusing and it is a little bit complex. So if you have watched this video to its entirety, I mean, many congratulations to you that at least you are able to understand it. And sincerely from my side, I tried my best, and you need to maybe rewatch this video again or write down the formula and maybe practice with the financial calculator 1 or 2 times to remember it. Thank you guys. See you in the next video.